Okay, so today we're going to be dealing with 1.6, which is inverse functions. So in 1.5, we dealt with a lot of composition of functions, which we'll have to have that kind of skill nailed to be able to do checking for inverse functions. So when we check for an inverse function algebraically, there is a process that we do. With the following example, f of x equals 4x minus 1. If you have an f of x instead of a y, remember g of x, h of x, f of x, y equals, those are all equivalent to each other. They're interchangeable. You can use one or the other. So if you are starting out with an f of x or g of x or something like that, your first step in checking for inverses is going to be saying, replacing that f of x with a y. Okay, so once we do that step, now what we do is literally switch our x and our y. So this and this are switching. Everything else stays where it was originally. So we're now going to have x equals 4y minus 1. Once we've switched out our f of x with y, switched literally our x and our y in their places, now what we want to do is solve for y or isolate y on either side of the equal sign, so whichever one works best for you. The first step right now in doing that is going to be adding 1 to both sides to give me x plus 1 equals 4y. After this step, in isolating y, the last thing that I have is this 4 in front of it. Since 4 is being multiplied by y, we have to do the opposite, which would be dividing by 4 in order to get it away from that y. This leaves me with x plus 1 over 4 equals y. So what I can do now is I'm going to say, I think this is my inverse. I think so. I'm not positive, but I think so. So when we say something's an inverse, the way we write that, you can see over here, is f, and then we kind of say what this so almost an exponent of a -1. So we say f inverse of x. We don't say f to the -1 of x, right? This -1 and that exponent, you can see that, yeah, stands for the inverse. So I'm going to say that I'm claiming my f inverse of f of x is x plus 1 over 4. Now I need to verify this claim. In order to verify it, we need to do two different composition of functions. The first composition of function is f inverse of f of x. So what this one starts with is my f inverse, right? When we do a composition of function, the outside function of those parentheses is the one that we start with. So I'm starting with x plus 1 over 4. Every place that I see an x in my original function, I'm going to replace with the entire other function. So I'm starting with x plus 1 over 4. I'm replacing this x with 4x minus 1, but everything else stays the same, right? So now I have to continue adding on the 1 and dividing by 4. Okay, I want us to get the other one set up before we do anything else with it. So eventually, the next one I'll have to take is f of f inverse of x. Okay, so in setting up this one, my original function is my f of x function, so 4x minus 1. So I'm going to start with 4. And now I'm opening up a parenthesis because I see I have an x, which means I'm replacing this x with my entire inverse function. So replace this with x plus 1 all over 4, and then finish up with the rest of my original function minus 1. So if something is in fact an inverse, okay, if this function is in fact inverse of my original function, when I verify by taking the two compositions, I should remain with a single x. Okay? If I get down to a single x on both of these, then it was in fact an inverse. Looking at this first one, plus 1 and minus 1. those are going to both cancel down to 0. So now I'm left with 4x over 4. These 4's cancel, and I end with just an x. So my first one's good, right? I ended with an x. I'll also get my second one. When I had this 4 distributing to this function where I have 4 in my denominator, that's the same thing as writing 4 times 1/4. We know that these 4's cancel just down to 1. So I can do this process of canceling my 4 in my numerator with my 4 in my denominator, leaving me with x plus 1 minus 1, which cancel, and I'm left with just x. So what I can say is this was, in fact, an inverse function. So I circle this up or box it up and say, yep, that was the inverse. Okay, and we are going to talk in the next part about why these inverses are helpful to us. So if you need an additional example of this, I can get you another video. We can talk about it in class. But the next kind of skill we're going to move on to is determining whether or not a function is one-to-one. Okay, so you've determined whether or not a function is an inverse of another function and finding that inverse on your own. But what about one-to-one? So basically a one-to-one function would be one in which their xy coordinates are literally the exact mirror of each other. So a one-to-one would be if one coordinate is 4, 5 in this function, then in my other function, it would be 5, 4. So every single x and y coordinate are just completely flipped. So let's ask, are the following two functions one-to-one? Or is the following function one-to-one? So f of x equals 3x plus 4 over 5. So if we can replace every x with a on one side of an equal sign, and on the other side every x with b, and finally get down to a equals b, then the function is one-to-one. So I'm going to show you two examples, one when it is one-to-one and one when it's not. So in this example, I start out, my function is 3x plus 4 over 5. So in this first one, I replace x with a, and in the second one, I replace x with b. If I can get down to a equals b, then it's one-to-one. If not, then it's not one-to-one. So replacing this, the first thing I'm going to do is if I can do something to both sides of the equal sign, then I'm fair enough to do it. If I want to get 5 out of my denominator, what I have to do is multiply by a whole number of 5. Right? That's going to cancel anything out of my denominator, leaving me with 3a plus 5, or 3a plus 4, sorry, and then 3b plus 4. Again, if I want to get rid of this 4's on both sides, with the goal in mind to get a equals b, I can do so by subtracting. It can be 3a times 3b. My last step in getting me to a equals b would be dividing by 3. I do, in fact, get a equals b. So because of that, this function is a one-to-one function. Okay, so let's go to another function. You can kind of tell early on whether or not they're one-to-one based on the way that your process is happening. So this is going to be x squared minus x to the 4th. Okay, and I want to know, is it one-to-one? So I replace every x with a and every x with b. Okay, so can I do anything to this function in which I would get down to an A equals B. You start asking yourself this question. You should be seeing, well, I can't add on an A because I don't know what that A equals, and I can't add on a B, right? If I add on A to the fourth, I just get it over here. And if I add on B to the fourth, I get that over here, right? So no matter what I'm doing, I have too many variables in play here in order to ever cancel this down completely to A equals B. So A does not equal B, so it is not 1-to-1. Okay, so we dealt with two different processes here. One was finding an inverse and verifying if it was in fact an inverse, and then also verifying whether or not a function is 1-to-1. Okay, that's it.